Married Monday, the 7th of December, okay? Geometry, we discussed the test already. Now we are going to be able to, you guys will be able to classify triangles by angles and sides, okay? So we're going to learn about triangles, and we're going to say, if we can organize them or classify them, say what they are more specifically, by both their sides, the types of sides they have, and the types of angles. Now, a triangle has how many sides? 3, okay? So a triangle is officially a polygon with 3 sides, okay? So a polygon, that's what the grandma said when her parrot flew away, okay? Polygon. Anyway, that's the Mr. Titus joke, okay? So a polygon just means a many-sided figure. So we're saying, more specifically, this is a polygon with 3 sides. Kenny, that got you way too well. Okay. So we have this triangle to the right. The triangle has points A, B, and C there. Okay. We can name this triangle in a couple of different ways. Okay. So we can actually write out the word triangle, and we can use the 3 points of the triangle in any combination. So we could say it in ABC. You could do CBA, CAB. You can pick any order of those 3. So any of the 6 combinations you could do.
It's almost as good as the penguin joke.
That was good. All right. Another way we can do this is a lot of times we end up having symbols, right? Like the line, you could write out the word line, or you could put the symbol for line. Okay. Same idea. We can do a symbol for the triangle and do the same thing, triangle ABC. And once again, you could have those in any order you want, okay?
Mr. Consul?
Yes.
Penny.
I guess. All right, so we can classify triangles by their sides, okay? We said we can classify by their sides and angles. First, we're going to talk about their sides, okay?
So I could have a triangle C or ACD.
Yes. Okay.
This is going to start getting annoying for me.
Okay, so we first have a scalene triangle, okay? This triangle called scalene. It has no congruent sides, okay? What's congruent mean?
Not. Similar.
Okay, congruent means what's the same?
The 2 lines. Or a
What's the same about them?
equal. Same number.
What's the same number?
They're degrees.
So for angles, it is.
A.
Yeah, thank you. Okay.
Jesus.
Yeah, no, we're gonna say like darn or gosh. Okay. Anyway, so it's the sides being congruent means they are the same length. Okay. So for example, okay, guys, stop. So for example, okay, I'm just making up random lengths. Let's say this side is 5, this side is 3, and this side is 2. Okay. Are any of those the same length? No. Okay. So this would be a scalene triangle because they're all different lengths. Okay. Because none of the sides are congruent to each other. We have an isosceles triangle, which has at least 2 congruent sides. Now, what do these little tick marks here mean?
That these 2 are congruent.
It shows that they're congruent to each other. Because they both have 1 tick mark, it means they're congruent to each other, okay? So there we see it has at least 2 congruent sides. Now, I know we say at least 2. We see those words at least. But honestly, if it has more than 2 sides, aka 3 sides, being congruent, we don't call it isosceles. It technically is, but we have a more specific name we use for that, which is actually the equilateral triangle, which has 3 congruent sides. And as you can see on the equilateral triangle, these each have 2 tick marks, meaning all of them are congruent to each other. Mr. Collis, why are there 2 tick marks instead of 1? Really, you could have any number of tick marks. You could have like 5,000 tick marks on there, although that'd be obnoxious. Because as long as they all have the same as each other, they're congruent to each other. Kenny?
So are they always going to say, like, if they're not to scale, or they're always going to say not to scale?
It won't always say it. We're going to assume they're not to scale unless we're told otherwise.
Okay.
Well, excuse me. We're going to assume they could not be to scale unless we're told otherwise. Does that make sense?
Yeah.
Okay. Now, here, as we see, if we flash back to the isosceles triangle, which is spelled a little weird, right? Okay. These sides that are called congruent are called legs, okay? So the 2 congruent sides are called legs, kind of like how your legs are the same length, or at least pretty close to the same length, okay? Same idea. These legs are going to be the ones that are the same length, and the base, regardless of which way the triangle is facing, whether or not the base is actually on the bottom, will be the non-congruent side. Now, if we look at the word equilateral, going over to the third triangle, equilateral, what does that kind of look like? Equal, okay? And that means same, right? Okay. Lateral. Does anyone know what lateral means? Side to side. Very good. Lateral means sides. Okay. Lateral is talking about side to side. Okay. So if you're talking about lateral movement, you're talking about movement to the sides to sides. Okay. So when we're saying equilateral, we're saying equal sides. AKA the sides are all equal. Does that make sense to you guys or no? Okay. And I'm just trying to give you guys tools to help remember these. Oh, equal. Okay. Continuing on, unless anyone still needs this. All right. Now we can also classify triangles by their angles. Okay, and I'm going to be lazy and do the angle symbol here. But if you want to, you can write out the word angle as well. We can classify triangles by their angles. Okay. So we have these good-looking triangles, the acute triangles. The acute triangles have 3 acute angles. Okay, they have 3 acute angles. All 3 angles are acute angles. Now remind me, what's an acute angle?
It's less than 90 degrees.
It's less than 90 degrees, but it's also more than 0 because otherwise it wouldn't be an angle. Okay, so we're going to say that that our x is going to be somewhere between 0 and 90 degrees. Okay, so our angle measure x is going to be somewhere between 0 and 90. Okay.
0 and 89. It can't be 90.
No, it's somewhere between 0 and 90 because it can't be 90. So it's less than 90, which means it could be all the way up to like 89.999 repeating forever, okay?
If you just do and repeating, it just comes out to be 90.
Well, that would be so close that wouldn't it show up as 90 on a protractor?
It'd probably look like that to the naked eye, yeah. But if you're like use like a microscope or some sort of technology, then we could actually see it for what it really is, yeah. Good question. It probably would look on a protractor like it's 90. A right triangle, okay, it's not just that it's correct, but it has 1 right angle. Now remind me, what's a right angle?
It's opposite of the left angle.
Okay, 90 degrees. It is opposite the left angle, okay? It's 90 degrees. And we see here, is this even marked to be a right angle in the picture? Yeah, the little box tells us that's a right angle, okay? Now to right angle, the 2 sides that are not, the 2 sides that are touching the right angle are called the legs. The side opposite the right angle, or it kind of looks like it's the right angle box is pointing toward the side, is called our hypotenuse, okay? You guys might have even heard that word hypotenuse before, right? Raise your hand if you've heard the word hypotenuse before, okay? Probably, a good chunk of us, okay, have heard that before, okay? Okay? Now, does anyone remember what the total, all 3 angles in a triangle add up to? 180 degrees, right, okay? So if one of these angles is 90 degrees, okay, these other 2 have to add up to 90 together, right? Does that make sense to you guys? Okay, because if one's already 90 and they add it to 180, well, we take away 90, that leaves 90 degrees left for both of these 2 angles to add up to, okay? Does that make any more sense to us? Okay, so that means they both have to be less than 90 then for them to add up to 90, right? They can't be 90 and 0 because you can't have an angle at 0, okay? So that means they both have to be less than 90, meaning the other 2, okay, meaning that the other 2 angles are acute in this scenario, okay? So maybe you write that in there and draw a little arrow there, okay? Write that in underneath. You have a little bit of space underneath, okay? And say, hey, that the other 2 angles have to be acute if there's a right angle, okay? Kenny.
So then, but one couldn't equal like 89 and the other equal 1.
It could actually. It could be 89 degrees in one. Once again, it would look to the naked eye as if the angle is really 0 and non-existent. But if you were to actually like zoom in big enough, or it was a big enough picture, or you're using technology, then you could actually see that.
So wouldn't that throw off the right angle?
No, so it wouldn't affect this being a right angle because this could still be 90 as long as the other 2 add up to 90.
It could be longer than accommodate.
Yeah. Just the other sides would have to stretch out, and so the other things would have to move around to accommodate that. Yeah. Yeah, I love that you're kind of thinking spatially here, though. Okay. So we have an obtuse triangle. An obtuse triangle has 1 obtuse angle. Does anyone remember what an obtuse angle is?
It's still bigger than
Wider than
It's fat. It's bigger than 90, but it's less than what?
180.
Okay, so our x, our angle measure, is somewhere between 90 degrees and 180 degrees. It could be anywhere between there. It could be exactly like 130. It could be 90.01. It can be 179.99999. Okay, it can be anything. Okay. Now, here, does this look like this angle up here is an obtuse angle right now?
Yeah.
It does look to be more than 90, okay? 90 degrees would be probably about here, right? Okay. And so it does look like it's more than 90, so we would say, okay, that's obtuse. Now, if one of the angles is obtuse, we know since all these have to add up to 80, that means the other two have to be acute, right? So we can draw an arrow here. Okay, the other two have to be acute for this triangle as well. So not only is that true for the right triangle, it's also true for the obtuse triangle, that the other two angles have to be acute if one's obtuse or one's right. Any questions on how we can know that? All right, and then last but not least, we have the equiangular, okay? Equal, we say that word again. What did we say equal kind of looked like? Equal, okay. Angular, what do we think that talks about? Angles, okay? So this time we're going to say a triangle with equal angles, okay? So this triangle will have 3 congruent angles, okay? So this triangle will have 3 congruent angles. And we can see this even being marked here by these arcs, that these are all 3 congruent to each other. Now question, if these are all congruent to each other, okay, Wolverine, what would each angle have to be?
60 degrees.
60 degrees, okay? Each angle would have to be 60 degrees, so each...
So they have to be equilateral and equiangular.
Ooh, that's a great question, okay? If it's equiangular, is it also equilateral? That is actually true. We'll learn about that more later, technically speaking. But an equiangular triangle, okay, is always equilateral, okay? And maybe even you guys have some room above, okay? A gap between the sides and the angles, right? So a gap between this slide and this slide, correct? You guys have that?
Not really.
Okay. You have like a very small gap, okay? You get enough to write like one little note in, right? I guess, okay? So maybe you can write in,
72.
like you could put like, here, let's restart that. Maybe say, if one, then the other, and put an arrow to equiangular and an arrow going up to equilateral. Would that maybe be a good thing to remember? Maybe even a helpful way to remember. Hey, if it's equilateral, it's also equiangular. If it's equiangular, it's also equilateral.
Are we going to have to do proofs over these?
Don't give them ideas.
Like starting today?
That's my goal. We've been over this, okay?
No, it's not. Are we starting proofs today?
No. Yes.
Your wife has style.
Thank you. I mean, I think one thing. I think the brown and the black. I think it clashes, but
I think it's
you know what?
black and black.
She likes it.
Is Married Monday just so you can flex that you have a wife now?
Basically.
Yeah, that's...
Okay. No, it's her way of participating with my gimmicks, which is like how like I have like the perfect wife for me. So is that not only is she's like, yeah, you can do your gimmicks, and they're stupid or whatever. No. She's like, I want to be a part of this. Anyway, let's continue on.
Dude,
So we have the following triangles, okay? Or excuse me, let's actually go back one more second. So an equiangular triangle, if every angle is 60 degrees, that means every angle is acute, right? Okay, so is an equiangular triangle technically an acute triangle?
Yes.
Yeah, it is, because it does have 3 acute angles. So an equiangular triangle is technically an acute triangle. It's just more specific. So if we're ever saying what type of triangle is it, classifying by the angles, because you can classify both ways, sides and angles. If we're saying, hey, by angles, what type of triangle is it? You would always answer equiangular if it's both, because this is more specific, because this gives you more information than just saying it's acute. Does that make sense? Okay, so if you're ever answering that question, you wouldn't say acute if it's equiangular. You would just say equiangular because it's more accurate. Okay, you guys ever see on tests? It's like give the best answer or the most correct answer. Okay, it's kind of like that scenario. Like this gives you the most information.
Okay, I have a question.
Yes.
Can we shorten any of these words?
No. Great question. You can always write triangle with the shape though.
I can't write try.
I
feel like...
I'd prefer you just do the shape if you're gonna do that.
I'll use that.
Okay, let's look at these following triangles, okay, at the bottom of this page, okay? So we see these 4 triangles, and I want you to classify them by both the sides and the angles by looking at them, okay? So we're going to use the eye test, okay? So if you look at number 1, letter A, we're classifying by the sides. So what do we think this triangle is by the sides? Do we think it's scalene, isosceles, or do we think it's equilateral? Let's look back at our notes. Okay, Bailey, what'd you say?
Scalene.
Scalene. Why would you say it's scalene, Bailey?
None of the sides are congruent.
Very good. I'd agree 100% with that, okay? None of the sides are congruent, so it is scalene. Good job, Bailey. Let's look at letter B. Classified by the angles, okay? Do we think this is acute, right, obtuse, or equal angular, okay? Dylan Dowell.
Obtuse.
I agree with you. It does look to be obtuse. I think this top angle up here is an obtuse angle. It looks to be bigger than 90. And so it's obtuse. Okay, so that makes the triangle obtuse. Questions on that? Okay, I want you guys to try the other 3 triangles on your own, okay? Let's look at number 2. Elizabeth, what did you classify number 2 by the sides? Equilateral, I agree with you, okay? We know all sides are congruent because they're marked to be so, okay? So if all sides are congruent, we know it's equilateral triangle. What's that automatically tell us? What kind of triangle is that, Quentin?
The other triangle.
The other one, equiangular, okay? Equiangular.
Dude, you could
How about everyone say equiangular with me right now, okay? Equiangular. Okay, equiangular. Say it one more time. Equiangular. Okay, good. Okay, let's look at the third one. Okay, classifying this one by sides. What do we think this one is? Okay, Elizabeth. I would agree with you. It is scalene.
They have to be in that order.
None of the sides are marked. No, they don't. I'm just keeping it consistent so that way everyone can understand it better. Okay, Seth.
Is it ever possible to have this isosceles right triangle?
Yes, it is. We'll actually look at that.
Oh, you got 45 degrees.
All right. Any other anyone want to? Excuse me. Let me restart that sentence. Okay, that was really bad. Anyone want to tell me what they would classify number 3 by the angles?
Right, dude, I got this.
Okay. Go ahead, Kenny.
It'd be a right triangle.
It would be a right triangle. That is correct. That is right. Okay.
It's a right angle.
Because it has a right angle. Okay. Let's look at number 4. Okay. Bailey, what would you classify number 4 by the sides?
Acute?
No, by the sides you said it was. You're talking about angles. By the sides you called it something else though.
The letter
Okay.
A. A option.
Oh, isosceles.
Isosceles.
Yes, that's what you're trying to say. I got you. Isosceles. It kind of looks like it's like isosceles. Okay, isosceles. Okay. What would we call letter B by the angles, Bailey? Acute. Because we know all the angles are acute. We don't know it's equiangular. Okay. It looks like it might be right, but do we know for sure?
No, sir.
No, we don't know for sure. Okay, don't put it away. We don't know for sure. Okay, because not all the angles are marked, and because it's not equilateral. Okay.
It's not because it's not an equal
Tyler. Yes, good luck. Okay, Kenny.
So I was talking to my dad over the weekend, right?
Okay.
And I realized it would not be that hard to move the car. We just need 4 car jacks, and we could just
Yeah, lift
lift
them
it
all at the same time.
like off the tire. They go on the tire, and you just jack up the car a few inches, and we could just move your whole car, dude. Just 2 different spots in the
Mr.
parking lot
Costello,
just every day.
don't worry about it. Not a senior break.
Like, why are you like talking? Anyway,
And then I
Seth.
thought about it.
If it was an
We
equal,
have parking lot.
angle, or then it would be equilateral.
Penny.
Yes.
You guys scared me to bring my car to school.
You should be scared.
All right. So we want to sketch an example of the type of triangle described. If we continue on to the next page here, guys, stop. Voices off. Voice off. Voice off. Voice off. Thank you. All right. Stop. Thank you. Sketch an example of the type of triangle described, okay? So each of these were given 2 descriptions. And I want you to mark the triangle to indicate whatever information is known. So like if you know angles are congruent, mark that. If you know sides are congruent, mark that, okay? So on number 1, I want you to draw an isosceles right triangle. I want a triangle that is both isosceles and right. On number 2, I want a triangle that's both obtuse and scalene. 3, a right equilateral triangle. On 4, an acute isosceles triangle. One of these 4 is not possible, okay? For that one of the 4, I want you to write down not possible. I want you guys to go ahead and work on this one now. Work on these 4 right now. So there's more than one right way these can look on some of them, okay? An isosceles right triangle, okay? I saw a few of you had them like this. Now, they really could be facing any way, But the two congruent sides have to be the sides touching the right angle. Because, does anyone know a special factor about the hypotenuse of a right triangle compared to the other sides? The hypotenuse is what compared to the other two sides? Does anyone know?
It's double.
It's longer. It's not necessarily double. It's always longer than the other two sides. So, for the isosceles triangle to have the hypotenuse longer than the other two sides, could the hypotenuse be the same length as one of the other sides? No, it can't be both the same and longer, okay? An obtuse scalene triangle. This could be any triangle with an obtuse angle, and the three sides are not marked congruent. So a lot of you had something similar to this. The right equilateral triangle, that one's not possible because if the right triangle, it means it has a 90-degree angle,
That just looks like
and one side's longer than the others.
It looks like an L.
An equilateral has to have all the angles be 60 because it's equilateral and it's also equiangular, and all the sides are be congruent. So you can't have all the angles be 60 and one angle be 90. You can't have one side being longer than the other two if all sides are the same. So they can't mix. Okay, Seth.
You were even able to learn about that side triangle. It would just be a diamond.
Sorry, say that one more time, buddy.
If you could even connect that, just end up being a diamond.
Maybe. I don't think you can really do it even. So, an acute isosceles. Okay, this is going to be any isosceles triangle, where two sides are congruent, and the angles are all less than 90 degrees. Okay, so I just drew something pretty similar to what we had for the isosceles triangle picture earlier. It just flipped a different direction. Okay, Gregory. Yes, good luck. Okay, Dylan, did you get on here number 1? The two congruent sides cannot be the hypotenuse because the hypotenuse is longer, okay? Any question on this before we move on? Okay? Let's continue on. The triangle sum theorem, okay? Triangle sum theorem. Sum means what problem are we, what kind of problem are we doing? Adding. Okay, very good, Seth. Okay, we're adding things up. So the sum of the measures of the interior angles of the triangle. So we add up all the angles of the triangle. We get 180 degrees.
I thought we were in section 4. I mean 5.
Yes.
Why is it?
It should say 5, shouldn't it? So that means if we add up in this triangle the measure of angle A plus the measure of angle B plus the measure of angle C, what do we get? 180 degrees. Mr. Costle, why doesn't it call it angle BAC? Why is it just calling it angle A? Well, right now, if we're saying angle A, how many angles could we possibly be talking about? Just the one. So do we have to be more specific if we already know we're only talking about that angle? No. But earlier, like on other problems like we've had before, there'd be like more stuff going on, and there'd be like an angle over here, and this would be like D, so you can be talking about DAB, or angle BAC. You don't know which one. You're talking about the inside or outside one. But right now, as it is, you're only talking about that one angle when you say angle A. Yes. So, using the fact that all three angles have to add up to 180 degrees, let's find the missing measures of this first triangle. So if measure angle A is 42 degrees, measure angle B is 52 degrees, how could we figure out the measure of angle C? Raise your hand if you could help me figure out the measure of angle C. Presley, go ahead. Very good, very good. We could add the two angles we know and subtract the total from 180. So what's 42 plus 52? 94, very good. So we take 94, we take 180 minus 94. Does anyone know what we would happen to get?
86.
86, very good. We do happen to get 86 degrees. So what's the measure of angle C? 86 degrees. So now, could we tell what type of triangle this is based upon the angles?
Yes, sir.
What would it be? Based upon the angles, it'd just be an acute. So I'm not worried about the side lengths right now. I'm saying, hey, just on the angles, this is an acute one, okay? And we would actually know it's a scalene, but we actually don't know. We don't know that yet, even though it is a scalene. We don't know that yet how to know.
See right there.
Okay. So if we look at number 2. If the measure of angle A is 45 degrees, measure of angle B is 45 degrees, how could we figure out the measure of angle C, Tyler? Add them together and subtract that from 180, right? So 180 minus 90 is 90. So measuring angle C is 90 degrees. So what type of triangle is this based upon the angles, Dylan?
Right.
It is a right triangle because it has a right angle. Very good.
So what? Wait. No.
It's easy like that. You just add them together.
Wait, wouldn't a right angle technically be obtuse?
No, because obtuse is anything between 90 and 180, and so 90 is not between 90 and 180. 90 is 90. Okay? So it's the way it's defined. It's not saying 90 or bigger, it's just saying bigger than 90. So we have this blank here, it's the long blank here. It's really just saying corollary. Has anyone ever heard that two things are correlated? Okay. What does it mean then? Those of you who've heard something is correlated, they're similar, they're related. Okay, they're similar or related. I really like those two words. Okay, they're similar or related, or they go together. Okay, that's what correlated means. Okay, so corollary is just going to say it's kind of the same idea as correlated. Okay, it's something that goes with a theorem. Okay, so it's a statement that may be proved easily using the theorem. So like we have the theorem. And so, that means this must be true. So if we know this, that has to be true. Okay, duh, kind of a thing. Or it follows from a theorem. So we have this triangle sum theorem which says, hey, all three angles have to add up to 180. So we have this corollary to the triangle sum theorem, okay? It's easily followed from the triangle sum theorem. So because we know all the angles have to add up to 180, we can say the acute angles of a right triangle, okay? So if we have a right triangle, these two angles have to add up to... Okay, so if measuring angle C is a 90-degree angle, we can take 180 and subtract that by 90. And we know angles A and B have to add up to what? 90 degrees. So that means angles A and B are what if they add up to 90 degrees? We have a special word for that, meaning they add up to 90 degrees. It might be on a poster on the wall. Complementary, okay? That poster behind Bailey over there. Okay. Complementary angles. Okay. Complementary angles. Okay. Did I spell it wrong? No, I didn't. Okay. No, I did spell it wrong. My goodness, Mr. Call. So this is an I, not an E. I hope not. Okay. That should be an I, not an E. L-I-M.
No, I get that. I just thought of something funny.
Lim. Okay. Complementary angles. Okay. So if you have a right triangle, the other two angles that aren't right have to be complementary because they have to add up to 90 degrees. Question on that? Alrighty, continuing on. So we have this triangle here. Yes. We know this angle up here is x, this angle down here is x plus 20 degrees, and this angle down here is 2x minus 40 degrees. If we know these three things, is there a way we can figure out what x is or what each of these angle measures are? Okay, raise your hand if you can help me out with this one. Okay, go ahead, Kenny.
X plus 20 equals 2x minus 40. No.
Okay, I'm actually going to disagree with that. We could do x plus 20 equals 2x minus 40 if we knew this angle was congruent to this angle.
Yeah.
It's me. But do we know those are congruent?
No, sir.
As of now, we don't. So unfortunately, we can't do that one. Elizabeth, what are you thinking?
X plus 20 plus 2x minus 40 equals 180.
Okay, x plus 20.
Plus x too.
We do have to add that plus x, okay? So essentially what Elizabeth did here, okay, very good, Elizabeth, is saying, hey, if I add up all these three angle measurements, okay, I could even put them in parentheses so we can see them, so we might be able to see them better. If I add up each of those angle measures, I'm going to get 180 degrees because they all have to add up to 180 degrees. Does that make sense or no? Any questions on that? Okay, and we don't need those parentheses there. I just put them there at the last second to try and help us maybe understand that or visually see that. Okay, so now we can combine like terms. What are some like terms we see that we can combine? The x's, okay? X plus 2x plus x. What would those add up to be?
4x.
4x, very good. And then 20 and a negative 40 add up to be what? Negative 20. 4x minus 20 equals 180 degrees, okay? Now, how could we solve this problem? What would we do next, Lauren? Very good. We would add 20 to both sides. Get rid of that 20 with a 4x. Negative 20 plus 20 is 0. 4x is equal to 200, okay? What would we do now, Quentin? Divide. Very good, very good. Divide by 4. You must have had a good math teacher last year, okay? X is equal to 50. So now, we wanted to solve for x. We did that. What else do we want to do?
Now we plug it in.
Plug it in to find each of the angle measures. So we know this one angle measure is 50 degrees. What would another angle measure be?
100.
The bottom left will be 70.
The bottom left would be 70. 50 plus 20 is 70. So we know 50 degrees, we know 70 degrees. What's our other measure?
We're scaling. 60.
60. 100 minus 40, 60 degrees. So our three angle measures are 70, 60, and 50 degrees. Our x was 50. And now we can classify this by the angle measures. What type of triangle is this based upon just the angle measures? It is an acute triangle because all three of these angles happen to be acute. Now, if we looked at this picture originally, would we have said we think this is acute?
Yep.
Maybe, maybe not. Some of us might have argued, oh, that might be right or scaly or right or obtuse. We don't know. Okay. But now we know definitively what it is. Questions on that?
We put 5, 4 on every single one of these zeros.
You're right. So let's go to the next page here. Here we're going to talk about interior versus exterior versus outerior angles, okay? So the interior angles are the angles inside of a triangle, okay? So if we take this here, we actually just took a normal triangle, okay? And we extended these sides out longer, okay? You guys remember extending sides out longer on like the shapes last chapter? Same idea. So the interior angles are these angles kind of highlighted in red, or on your paper it's gray. Okay, and we know what about those interior angles? What did they add up to?
180.
Okay, so that's a really bad star. That's a slightly better star. Actually, a pretty good one, okay? These add to 180 degrees. We know that. Okay, so the other type of angles we're going to talk about then are the exterior. Or we joked about outerior, okay? The exterior angles are going to be the angles outside, okay, when we extend these shapes, okay? So, and they're going to be the ones that make linear pairs with the interior angles. Remind me, what's a linear pair?
They make an X. They're next to each other.
They're next to each other and they have supplementary. They add to 180. They form a straight line, okay? So if we're talking about this interior angle right here where my finger is, this exterior angle with that little blue hue or gray hue on your paper, okay? That's the exterior angle. Okay, this angle, either of these are exterior angles. Up here, this is an exterior angle, or we can make another one over here if we wanted. Okay, so now let's just say I put a random angle measure, okay? Can you give me an acute angle?
Let's go 2, baby.
2?
Yep.
Okay, so we're going to call this angle 2 degrees. Okay, it doesn't look very realistic, but we'll call it that anyway. What would that make this exterior angle?
178.
Yes, 178, sorry. It's 180 minus that because they're a linear pair.
Let's go, baby.
Okay. Gregory, give me another acute angle. Oh my gosh. Okay, 5 degrees. This one is now 5 degrees. Okay. What would that make either of these exterior angles? 175 degrees, because they're both linear pairs of that. So it makes either of these 175 degrees.
And the other one opposite to it is 5.
Okay. Yep, and the other one opposite would be a vertical angle. Yeah, we don't need to know that, but that is true, okay? Now the other interior angle, if this is 5, this is 2, what's this one have to be?
Just throw a 1.
Okay, well, actually, it has to be mathematically. It has to add up to 180. So this one has to be 173. There's like no other choice except for it to be 173 degrees. Okay? So that means this exterior angle is then 7 degrees.
You're welcome.
Okay? Yeah, you guys took what could have been an easy example and made it not that way. So now we're going to try adding up the exterior angles. But what we're going to do is we're going to add up just one exterior angle at each of these. Because we really could say, oh, there's another exterior angle here. We can make another exterior angle somewhere else. But if we just add up one exterior angle at each point, okay, and we add up 178 plus 175 plus 7. Okay, well, what's 5 plus 8? 5 plus 8. 13 plus 7. 20. So carry the 2, drop down the 0. What is 2 plus 7 plus 7? 16. So drop the 6, carry the 1. What is 1 plus 1 plus 1?
3.
What is that up to?
360.
360 degrees. Now, fun fact, okay, these will always add to 360 degrees.
It's a circle.
Okay, the exterior angles will always add up to 360 degrees. So if you just take 1 at each angle, okay, be careful that you're saying only 1 for each angle, though, okay? Maybe even write yourself a note of that if you might forget. You have to take 1 at each angle. Which leads us to this theorem right down here, which basically says this, the exterior angles theorem. The measure of an exterior angle of a triangle, or excuse me, that's a different one, never mind. That's a different one, never mind, sorry about that. Interesting, okay. So all the exterior angles, if you just take 1 at each angle, will always add up to 360 degrees, regardless of what measures you guys give me, even if they're obnoxious like 5 and 2. And then 173 by default.
Or 60, 60, 60.
Okay, or if you gave me 60, 60, 60, okay?
That was like the golden one, guys. No.
So this exterior angle theorem, moving on. The measure of an exterior angle, so here in this triangle we have angle 1's an exterior angle, of a triangle is equal to the sum, or adding, of the measures of the two remote interior angles. It's the exterior angle is equal to the sum of the two remote interior angles. Now, remote. Okay. Well, where do we guys see the word remote at?
Isolation.
Okay, maybe. What do you say?
Remote learning.
Okay, remote learning. Okay, remote learning. Okay, students that are remote learners, are they in the building or are they away? They're away. Okay. What about a remote control? When you use a remote control, do you need to be at the object or can you be a bit away? Okay, it's not attached, they're away, okay? So that's the whole point of a remote control, right? Is so you can control something remotely. Remote just means that you're away, okay? They're not attached, okay, like Kenny was saying, okay? So it's this idea of these remote interior angles are the interior angles not adjacent or not touching the exterior angle. So if this is our exterior angle over here, this is not a remote interior angle because it's touching. But these two are remote interior. They're not touching and they're interior. So if angle 1's the exterior, angles A and B are remote interior, but this angle C would be just a normal interior. Does the idea of a remote interior angle make sense to us or no? Quentin? Okay. Okay. So the remote part makes sense.
Yeah.
Okay. So that is away. So is this angle next to or not next to this exterior angle? It's not next to. Because next to is right here. This angle, does it make sense that this angle is next to this angle? Okay. Does it make sense that this angle is not next to this angle? Okay, you're saying that as a question. Okay. Well, these angles, are they literally touching?
Yeah.
Okay, are these angles touching? Okay, they're not next to each other. Are these angles touching? They're not next to each other. Okay? So that means they're remote if they're not next to each other. And these are remote if they're not next to each other. So if the exterior angle is up here, these are the remote two because they're away. If the exterior angle is down there on the bottom left, these are the remote two because they're far away. So whatever the remote angles are depends on which exterior angle you're talking about. Does that make more sense? Thanks for telling me that, okay? So what this theorem's saying, guys, is if I have this exterior angle, it's going to be the sum of whatever these remote interiors are. If we look back up to our previous example, 7 degrees is going to be the sum of the two remote interior angles. 7 is 5 plus 2. That makes sense. 175 is going to be the sum of the two remote interior angles. 173 plus 2 is 175. 178 should be the sum of the two remote interior angles. 5 plus 173, 178. Here's why that mathematically works every single time. Because what do these two angles that I'm pointing to right now, okay, these two angles have to add up to be?
102.
They have to add up to be 180. They have to, because they're a linear pair. Christian.
What if they don't?
then they have to. They're a linear pair. They literally do.
Then you cross math.
Then it's not an actual exterior angle. But an interior angle and its exterior angle have to add 180 because they're a linear pair, okay? Kenny, thank you. So, if these two have to add up to 180, then we could say, okay, measure of angle C plus measure of angle 1 have to add up to 180 degrees. And we also know that all the three interior angles add up to 180. So we also know the measure angle A plus the measure angle B plus the measure angle C add up to 180 degrees. So, if measure angle C and measure angle 1 add up to 180, measure angle A, measure angle B, and measure angle C add up to 180, C can add with both angle 1 and these other two angles add up to 180. They have to be the same thing. It's kind of like our congruent supplements theorem from before. They have to add up to the other same thing. So in this example, measure angle 1 is equal to which two measures added together? B and A. In either order. So in this example, measure angle 1 is equal to the sum of measures angles B and measures of angle A. Questions on that? Okay, heads up, guys. If we dial in for like a few more minutes, there's not going to be any homework, okay? Okay, take a breath, take a breath, take a breath. Okay. Okay. Continue on. We're going to do a problem about this. Now, these are hard to read, right? Okay. Up here at the top, this is 2z degrees. And at the bottom, this is 5z minus 2 degrees. And bottom left here outside is 145 degrees.
There's supposed to be a 1 in there as well. Let's see a line right after
Parentheses. Okay. So we have 145 degrees down here on the outside, the exterior angle. Angle A is really 2z degrees. Angle B is 5z minus 2 degrees. Now, do we have an exterior angle? Yes. And we want to find the measure angle B. Well, we know it's 5z minus 2. What are we going to need to do in order to find what the angle is? We're going to have to find z first to plug it in. Okay, Elizabeth, do you have an idea here?
Yeah.
All right, what would you do, Elizabeth?
We do 5z minus 2 plus 2z equals 55.
I would completely agree, okay? This is actually using that theorem we just learned about like 2 seconds ago. Shocker, okay? That I would make a problem right after we learn about something about that thing. Okay? We add up the two remote interior angles. The interior angle is not touching the exterior angle, and they're going to equal the exterior angle. Questions on the setup?
Yeah, why did you cross it out red again?
Because it was blurry. Okay, so now we add these, or we combine like terms to me. 5z plus 2z. Tristan, what is 5z plus 2z? Nailed it. 7z minus 2 equals 145. So we add by 2. 7z equals 147. Okay. Z is 21. 91. Are we done yet, though? Big picture, we wanted to find that so we could plug it back in, right? So we go back to plug this in. And we say, okay, well, 5 times 21, or tiny 1, minus 2. 5 times tiny 1 is 105. So the measure angle B is what? 103. 105 minus 2 is 103 degrees. Questions on that? All right. We will finish up the other two examples later.
Dude, I'm a